I can compare and contrast the probability of independent and dependent events. Now, to compare probabilities, you always need to work with percents. It is much easier to do that. So, which scenario has a greater probability of occurring? Scenario number one. In a bag, there are 5 red pieces of candy and 10 green pieces of candy and 5 blue pieces of candy. Oliver selects a red piece of candy, replaces it, then selects a green. Well, if you add 5 plus 10 plus 5, there are 20 pieces of candy. And Oliver wants a red one, and there are 5. He picked out, hoping to get red, then replace that piece of candy so the bottom number stays at 20. This is independent probability. And then wants a green. Well, there are 10 possibilities of green. If you type that directly on one line in Desmos, which I will do just to show you, 5 divided by 20, then multiplied by 10 divided by 20, and I'm going to compare, so let's make it a percent. By multiplying by 100, I get 12.5% that might happen. Now let's look at scenario number 2. In a bag, there are 5 red pieces of candy, 10 green pieces of candy, and 5 blue pieces of candy. So again, we have 20 possibilities. Kaylin selects a red piece, so she has 5 opportunities to get that. She eats that piece of candy and then wants a green one. But if she eats that piece, now there are only 19 left and there are 10 green possibilities. Then we multiply by 100 to find the percent probability that this will happen. So 5 divided by 20 multiplied by 10 divided by 20, then multiply by 100. And that gives us, oh, excuse me, I messed up. That's 19 at the bottom here because she ate a piece of candy. Sorry about that. That gives us a 13.2% probability that that will happen. So the answer is that scenario number 2 has a greater possibility of happening. Now let's look at this. It says you have 2 pairs of red socks. I'm going to go ahead and start adding these numbers up. You have 1 pair of blue socks. And you have 3 pairs of black socks. Let's read the 2 scenarios below and determine which one is more likely to happen. First, look at Desmos and realize you have 6 pairs. So we're doing 3 things here. We're choosing, then replacing, which makes it independent, and then we're picking again. So first, we know there's 6 pairs of socks, and you want to pick a red pair. Well, let's look. There were 2 pairs of red socks. Then you put that pair back, and you decide you want a pair of black socks. Well, there were 3 of those, and since you put it back, there's still 6. So we're going to come over to our calculator, put in 2 divided by 6 times 3 divided by 6. And then since we're comparing, we want to make sure it's a percent. So that would be, let's round, 17%, because 16.6 rounds to a 17% probability that that will occur. Now let's look at scenario number 2. You pick a pair of red socks, do not replace it, then pick a pair of black socks. So we're doing 2 things again, but this time it is definitely dependent. We started with 6 and we wanted red the first time, which is 2 pairs, but then we do not put them back. So our bottom number changes to a 5. Then we want a black pair. There were 3 of those. And we'll put that in our calculator, but remember, multiply by 100 because we're comparing and we want it to be a percent. So I'm going to put in 2 divided by 6 times 3 divided by 5 and multiply by 100 so that I get a percent, which is 20%. So which one is least likely to happen? It's not always what will happen the most times. Sometimes it's what happens the least number of times. So scenario number 1 is the least because it only has a 17% probability when the second one has a 20% probability. All right.